Assalamualaikum and hi. In this video, our team group 5 will explain on topic stress corrosion. So, this is all my team. We have 7 dearest groupmates. So, the topic we want to focus on is mechanism and definition of stress corrosion, type of stress corrosion, factor affecting stress corrosion, prevention, testing method, and consequence of stress corrosion. Stress corrosion (SCC) was defined as spontaneous failure by cracking of a metal under combined action of high stress and corrosion. Cracking process requires simultaneous action of corrodant and sustained tensile stress. Stress corrosion cracking (SCC) is a type of material degradation that occurs due to the combined effect of tensile stress and corrosive environment. This phenomenon can lead to sudden and catastrophic failure in structure and component, even if the applied stresses are significantly below the material yield strength. The mechanism of SCC involves several complex interactions between mechanical and chemical processes.
Types of stress corrosion. 1. Hydrogen enrichment. Hydrogen enrichment occurs when susceptible metal absorb hydrogen, causing a loss of ductility and load-bearing capability. Stress below the material's yield point can lead to cracking and brittle failure, also known as hydrogen-induced cracking or hydrogen attack. This process involves hydrogen atoms diffusing into the metal lattice, perform bubble at grain boundaries. This bubble can create pressure, potentially initiating into granular crack that compromise the metal's integrity. Second, sulfide stress cracking (SSC). Sulfide stress cracking (SSC) occur when steel and alloy react with hydrogen sulfide H2S, producing atomic hydrogen and metal sulfides. This hydrogen can form gas or diffuse into the metal, with sulfur reducing hydrogen recombination and increasing diffusion, worsening the environment. Stress corrosion cracking (SCC) mechanisms are complex and not well understood, requiring empirical experiments for reliable data as crack initiation, pitfall, and damage vary between materials due to the intricate interaction of metals and environmental factors.
Assalamualaikum. My name is FARISYA NABIHA binti HISHAM and my metric number is J22A0344. I would like to continue to talk about type of corrosion. Corrosion fatigue is a term used to describe cracking, both initiation and growth in material. Corrosion fatigue causes by stress and corrosive environments that break protective films and accelerate corrosion. Cyclic loading causes varying stress level influenced by stress intensity, alloy composition, loading frequency, temperature, and gas pressure. Next, chloride stress corrosion cracking is a type of intergranular corrosion and occurs in austenite stainless steel and under tensile strengths, under tension with oxygen, chloride ion, and high temperature. It often results in dry fracture near the material fatigue threshold.
Next, factor influencing stress corrosion cracking SCC have a material properties, environmental factor, and applied stress. AQILAH. Material properties have a composition. Other composition chromium and molybdenum increase SCC resistance, sulfur and phosphorus increase susceptibility. Contaminants, sulfur and phosphorus impurities create vulnerable spots that intake cracks. 2. Mechanical properties. Tensile strength, high yield strength material are more susceptible to SCC under tensile stress. Ductility and hardness. Low ductility and hardness make material more prone to SCC as they can absorb stress well. 2. Phase structure. Microstructure sensitized microstructure or martensite base, such as a sensitized stainless steel, increase SCC susceptibility. Grain size. Finer grain generally resist SCC better unless by contaminated or phase change. Environmental factor have a corrosive agent. Chloride penetrate protective oxide layer causing SCC in alloy like stainless steel. Hydrogen sulfide leads to sulfide stress corrosion cracking in high strength steel. Other chemical, ammonia, nitrite, and compound can induce SCC. Temperature. High temperature accelerate chemical reaction and diffusion rate increase SCC susceptibility. pH level. Extreme pH level value accelerate corrosive process, worsening stress-induced cracking. Okay, yang ketiga. 3. Apply stress. Type of stress. Tensile stress, most common cause of SCC induced by thermal expansion, residual stress, or external load. Stress concentration, localized stress concentration, promote correct interaction. Example, notch and pitch. Magnitude and distribution, elevate apply stress level or residual stress from matching welding or forming operation and lead to SCC is not properly managed or relieved.
Imagine a bridge collapsing, a pipeline bursting, or a crucial component in a power plant failing. These are all potential consequences of stress corrosion, a silent and destructive process. So, here are the prevention of stress corrosion. Firstly, material selection. We can choose materials with inherent resistance to stress corrosion, such as specific nickel alloys and certain types of stainless steel. Next, proper design. Design plays a vital role by minimizing stress concentrations like sharp corners and abrupt changes in geometry. We significantly reduce stress corrosion responsiveness. Heat treatment can further reduce residual stresses within the material. Thirdly, non-destructive testing methods such as surface treatments are our allies in this fight. Surface treatments and protective coatings can provide an additional layers of defense against corrosive chemicals. Lastly, operational practices. Materials and engineering techniques can be improved to increase resistance to stress corrosion by ongoing research and development. Thank you.
Okay. Next is testing method for stress corrosion. Testing method for stress corrosion, we have 4: U-bend testing, searing testing, slow strength rate SRR, constant lock test. U-bend testing, it's shaped like a U. It's bent to an extent and submerged into the caustic solution. If the material is ACC, the bent area will see the development of fracture. Second is searing testing. It have a C-shaped ring that inside machining notch. SCC is indicated by crack that emerge from the notch. Third is constant lock test. The susceptibility at a given stress level, it can be evaluated by using this constant lock test. Lastly is the slow strain rate SRR. SCC resistance is indicated by how long it takes for the specimen to fail. Better resistance, it have a longer time to fail. That's all from me. Thank you.
Consequences of corrosion. First, economy sector. Economic sector are also affected by corrosion. Corrosion kills industrial gear and equipment, resulting in lost production, higher maintenance costs, and downtime. Corrosion lowers product quality and raises reject rate in production, which has an impact on profitability. Actually, corrosion in electrical networks results in economic failures and power outage, which disrupt service and result in significant financial losses. Second, health and safety issue. Corrosion can result in the release of hazardous substances such as heavy metal or chemical into the surrounding environment. Worker and neighbor standards may inherit or come into contact with the toxic ladder to respiration problem, skin irritation, or more severe health issue, depending on the toxicity and contagion of the release substation. Last, loss of life. Environmental corrosion varies from corrosion as well. Leaching of corroded material, introduction toxic substation into ecosystem, harming aquatic life and contamination water supply. Moreover, corrosion related leaks from storage tanks and pipeline indicate natural habits and contribute to pollution. That's all. Thank you for me and my group members.